say, going to present a video about a few questions related to the topic triangle. So let us begin. The statement of the first question reads that in the given figure, AC is equal to AE, AB is equal to AD, and angle BAD is equal to angle EAC. Show that BC is equal to DE. For the solution, firstly, we shall mention what facts have been given to us. So AC is equal to AE. It means that this side AC is equal to AE, AB is equal to AB, this side AB is equal to the side AD, and angle BAD is equal to angle EAC. It means that this angle ABD is equal to this angle CAE. Now, if we add this common angle to both sides of the equation, then its equality would not be affected. So, adding angle DAC to both sides of the equation, we get angle BAC is equal to EAD. This means that this whole angle would be equal to this whole angle. Now, taking two triangles of this whole figure, triangle BAC and triangle DAE, we can write the following facts. BA is equal to DE. This has been given. And angle BAC is equal to angle DAE. This we obtained from the equation 1. AC is equal to AE. This also has been given. So by the side angle side congruence criterion, we can write that triangle BAC is congruent to triangle DAC. Hence, by CPCT, we can conclude that BC is equal to DE. This is how we can solve this question. Moving on to the next. The statement of this question says, prove that the sides opposite to equal angles of an isosceles triangle are equal. This is also a very important theorem. This property of isosceles triangles is very commonly used in solving questions. For this solution, we need to take a construction. Firstly, we have been given that angle B is equal to angle C. This means that this angle is equal to this angle of the triangle ABC. The construction is that we need to draw the angle bisector of the vertical angle which meets the base of the triangle at a certain point. I have drawn AP as the bisector of the vertical angle A which meets the base BC at a point C. This implies that angle CAP would be equal to angle BAP. Now, we need to prove that the sides opposite to equal angles, that is, the sides opposite to angle B and angle C. This means AB and AC are also equal. For this, we will take the triangles APB and APC. So, in these two triangles, angle PBA is equal to angle PCA. This has been given to us. And by construction, we obtain that angle BAP is equal to angle CAP. Taking the side AP, which is common to both the triangles, we can write that triangle APB is congruent to triangle APC by the angle side congruence condition. So, by CPCT, we can conclude that the side AB is equal to AC. Hence, this theorem has been proved that the sides opposite to equal angles of an isosceles triangle are also equal. The converse of this fact is also true. Let us move to the next question. In this, it has been asked to prove that the altitudes drawn to equal sides of an isosceles triangle are equal. Altitude is the perpendicular drawn to a particular side from its opposite vertex. So we need to show here that if a triangle is isosceles, then the altitudes to its two equal sides are also equal to each other. For this also, we need to take a construction. Here, I have drawn QY perpendicular to the side PR and RX perpendicular to the side PQ, and we have been given that PQ and PR are equal to each other. So, for the proof, I am going to take the two triangles QPY and RPX. Triangle QPY and RPX. In these two, angle QYP, this means this angle is equal to angle RXP, this angle. As by construction, I have taken both these as the 90-degree angles. Now angle YPQ, this means this angle, and angle XPR. This also infers to this very angle, and I have taken it because it is common in both the triangles, and PQ is equal to PR. This fact we have been given. So again, by angle side criterion of triangle congruence, we can infer that triangle QPY is congruent to triangle RPX. Hence, our theorem gets proved that QY is equals to RX, or we can say that for any isosceles triangle, the altitudes drawn to its equal sides are also equal to each other. This is how we can prove this important theorem. Let us move on to the next. This statement relates to the triangle inequality properties, one of which it has been asked to prove. The statement is prove that the sum of any two sides of a triangle is always greater than the third side. This fact we have been reading since early classes, but here we need to prove it. For this, I have taken a triangle BCD, this shorter triangle BCD, whose sides are BC, CD, and DB. Now I need to prove that DB is plus DC is greater than DC, or the sum of two sides of the triangle DB and DC will be greater than the base side BC. We can take it for any other two sides as well, but for convenience, I have taken these two adjacent sides. The construction required to prove it is that we shall extend the side CD of this triangle to a point A such that AD is equals to DB. This means that this side should be equal to this side. And further, we will join the point A to vertex B of triangle BCD. Now, in triangle ADB, this triangle ADB, we get angle DAB is equal to angle DBA. This is because in an isosceles triangle, the angles opposite to equal sides of the triangle are also equal. Using that very property, we can write here that angle DAB is equal to angle ABB. Now, and if we add, since both the angles are equal, if we add any other angle to one side of the equation, it will definitely be greater than the other one. So here what I have done is, I have added the angle DBC to the angle DBA of triangle ABB. This means this angle has been added to this angle. So the sum will be greater than angle DAB. Here I have written it, angle ABB plus angle DBC would be greater than angle DAB. So in triangle ABC, if we take this whole triangle ABC, we can find that B angle ABC or simply angle B is greater than angle BAC or angle A. So by triangle inequality theorem, we can infer that the side AC will be longer than BC. The triangle inequality property states that any side which is opposite to the larger angle of a triangle, will be longer. Using that very property, we can write that this side AC should be longer to BC because the angle opposite to the side AC, that is the angle B, is greater than the angle A, which is opposite to the side BC. So this side AC can be written as the sum of AD and DC. And since AD is equal to DB, this we have taken by construction, we can replace AD with DB. So we can write this equation as DB plus DC greater than DC. The same can be proved for other sides as well using the same properties. So we can say that the two sides of a triangle is always greater than the third one. Let us move on to the fifth question. That in the given figure, P is a point on side QR of triangle PQR and S is a point such that RT is equal to ST. Prove that PQ plus PR is greater than QS. Is a point. Firstly, it has been given that RT is equal to ST. This means that this part RT is equal to ST. And we need to prove that the sum of the two sides of triangle PQR, PQ and PR is greater than the side QS of triangle QST. For this, first we will take in account the triangle PQR. By the triangle inequality theorem, we can write that the sum of sides PQ plus PR is greater than the side QR. This side QR can be further broken into two parts, QT and TR, and can be written as their sum. So we can further express it as PQ plus PR is greater than QT plus TR. Since we have been given that TR or RT is equal to ST, this TR here can be replaced with ST. So this will give us our first equation, which is PQ plus PR is greater than QT plus ST. Now, if we take a look at the triangle QST with the same inequality theorem, we can write that QT plus ST will be greater than QS. This will give us our second equation. From both these equations, we can find that PQ plus PR is greater than QT plus ST, which is further greater than QS. Hence, from this final equation, we can conclude that PQ plus PR is greater than QS. Let us move on to the sixth question. In this, the statement is if sides LM and LN of triangle LMN are extended to P and Q respectively and X greater than Y, then show that LM is greater than LM. Firstly, we have been given a triangle LMN whose sides LM and LN are extended to points P and Q respectively, and the exterior angles have been named as X and Y. In this case, on the ray LP, we can find that this angle X plus angle LMN is equal to 180 degrees because they are forming a linear pair. Similarly, on the ray LQ, angle Y plus angle LNM will form 180 degrees due to linear pair. Now, if we take a number, for example 10, and subtract 8 from it, our answer would be 2. But if we subtract 6 from it, we would get 4. From this example, we can conclude that if from a same given number, a smaller number is subtracted, then the answer is greater than we get by subtracting a larger number from the same. The same thing is used over here. Since x is greater than y, if we subtract x from 180 degrees, it shall be smaller than y subtracted from 180 degrees. This is also one of the laws of inequality. So this implies that angle LMN is smaller than angle LNM. And hence, by the triangle inequality theorem, we can write that the side opposite to angle LNM would be longer than the side opposite to angle LMN. Hence, we can write that LM is greater than LN, and this is how we can prove this statement.